We often assume that an expert in a specific field naturally knows how to teach it. We expect that someone who has mastered a complex subject can seamlessly extract that knowledge and assemble it in someone else's mind. But the default operational state of a subject matter expert is entirely content-centric. They possess an exact understanding of the what within their discipline, but rarely possess the structural frameworks for the how. In our current digital ecosystem, this results in a very specific failure mode. Experts provide highly accurate, dense data, dropping a comprehensive PDF or a massive slide deck into an online portal, but they provide no structured environment for how that data should be absorbed. This matrix illustrates exactly where that learning transfer breaks down. You can see the subject matter expert plotted high on the vertical axis for content focus, but very low on the horizontal axis for learner focus. When content is simply broadcast outward without accounting for the audience receiving it, actual skill acquisition fails to take root. The information exists, but the learning does not. Mastering a discipline and engineering the acquisition of that discipline in others are two entirely separate technical skills. To bridge that gap, we rely on a rigorous, discipline-based intervention known as instructional design. Instructional design forces a vector shift away from the expert's content-centric bias, moving the process toward a deliberate, learner-centric architecture. While the subject matter expert delivers raw data, the instructional designer builds a methodology prioritizing how the human brain actually receives, processes, and retains that information. Instructional design operates on the principle that high-fidelity instruction is a predictable, mathematically structured system. That system operates by calculating a set of dynamic, shifting variables against strict, unyielding cognitive constants. To see how this operates, we need to unpack these realities and map them directly onto the industry-standard frameworks used to build modern learning platforms. Instructional design is a hard systems engineering problem applied directly to human cognition. Every learning situation begins with contextual variables: the audience, the content, and the outcome. These change constantly. But these flexible inputs must be calculated against the fixed rules of human biology, the scientific constants. These are the cognitive limits of memory, learning mechanics, and human motivation. Raw subject matter, regardless of how accurate or comprehensive it is, fails to transfer if it ignores these rigid constraints. To successfully translate the shifting variables through those strict constants, the system requires a highly precise processing engine. This chart details the ADDIE framework, the industry-standard algorithm used to resolve these inputs across 5 phases: analyze, design, develop, implement, and evaluate. Phase 1 is analysis. Before any content is drafted, the designer determines the learner's current entry-level behavior. The goal is to mathematically identify the exact gap between the knowledge the learner currently holds and the performance state they need to reach. This generates the first tangible output of the system, the training needs analysis. That analysis becomes the strict input for Phase 2, design. This is where the architectural blueprint is drafted. The instructional approach, the specific pedagogy, and the flow of the content are all locked in during this phase, long before a single piece of actual learning material is generated. Most importantly, the design phase establishes the evaluation strategy. It dictates exactly how the system will measure success. Defining success metrics must precede production. Otherwise, you risk total misalignment between what the teacher thinks they're teaching and what the learner actually absorbs. Together, the analyze and design phases act as a strict filter. They prevent the creation of arbitrary, ineffective content by forcing you to define the exact parameters of the problem first. With the blueprint finalized, the system moves from theoretical planning into production with phases 3 and 4, develop and implement. The development phase integrates media and technology to create the physical and digital outputs. Here you build interactive K-12 apps, the online modules, and the facilitator guides. Implementation is simply the live deployment of those customized materials to the target audience within their designated environment. But the system doesn't stop at deployment. Phase 5 is evaluation. This phase functions as a continuous diagnostic tool, assessing both the learner's understanding and the efficacy of the instructional process itself. ADDIE utilizes a dual-loop assessment model. The first loop, formative evaluation, assesses midstream to identify friction points and tweak the design. The second loop, Summative evaluation determines final performance and overall return on investment once the process concludes. Formative evaluation refines the instructional material itself, while summative evaluation measures the learner's actual mastery of the skill. This continuous feedback loop ensures the educational system constantly self-corrects, making ADDIE an iterative algorithm rather than a static checklist. While ADDIE was built for education, it shares an identical architecture with a common corporate framework, design thinking. The mandate to empathize with the user maps directly to analyzing the learner. And cycles to ideate, prototype, and test mirror ADDIE's mandate to design, develop, evaluate. Instructional design is essentially applied design thinking, heavily modified for the unique constraints of human cognition. The teaching-learning process, in recent times, has shifted away from passive, teacher-driven models toward experiences that are learner-driven and collaborative. The modern ecosystem demands material that is technology-driven, highly multimodal, and built for self-determined learners. Broadcasting accurate subject matter will not meet these demands if it lacks a rigorous pedagogical architecture to support it. By utilizing engineering frameworks like ADDIE, we apply a systematic approach to education, translating raw subject matter into verifiable, acquired knowledge.